Okay, welcome back to maybe our final thing on sorting. Well, it's the last set of slides about sorting, so okay, it is. Which means that on Wednesday, we actually do something completely different, which is really cool. It's about taking some programs and actually generating files, which may sound boring, but actually it's really cool because then you can look at your data in another program, and more importantly, be able to take some data in another program and open up inside Python. That's actually really, really handy because it turns out that there's an awful lot of data out there that is in the formats like Excel and so on. And yeah, being able to read the values out of an Excel file to be able to do further manipulation, it's actually really, really useful. You see, sometimes I spend an awful lot of time in this place, and we have access to a bunch of Excel files that we download to the PeopleSoft and so on, like grades and so on, and then sometimes I just run little analysis programs based on it, so it's really useful. However, before we get there, today we've still got to deal with sorting lists of things. Okay, now the reason why I called it things is because last week we learned how to sort lists of simple items such as values. Okay, so really that was sorting lists of values. So the values were integers and floats, as well as, well, I showed you how to sort strings, which of course provides this very strange little thing because we get things in alphabetical order, and if you stick in digits it gets really weird. All right, but in any case, I kind of left it off at the end by saying, well, what if we had like a list of students, and what would that mean to be sorted? And yeah, I think I showed you how we could sort it, so I'm going to go back and then cover that first. So we'll do the same thing, and I'll show you, just to remind you, the sorting algorithm. I'll pick the simple one, bubble sort. Then I will show you how we can fix it to sort a list of students. And because this type of thing happens all the time, yeah, guess what? There's stuff built into Python, which is really good because quite often you end up having to sort a bunch of things. Maybe students in this case, maybe laptops, sales items, whatever. Okay, so it turns out it is really straightforward. That's why there's only like 5 slides in this entire thing, in this entire slide set, but hey, we'll do it anyway. All right, so my time waste, okay, over here. There we go. There's a sorting algorithm that we had last time. That is, of course, just a bunch of integers. And what I've done is I printed the integers and I set up a nested loop. I went through the list a whole bunch of times. Every time that I went through, I compared the two items at position I and I plus 1. Oh, sorry, j and j plus 1 in this case. And I said, if I ever find that the value at data at j is bigger than the value at j plus 1, you switch them. And you just keep on doing this, and you repeat this a whole pile of times, and what you end up with at the end is a sorted list. Okay, so there we go. That's the before and the after. As what I said, this is by far like one of the world's worst sorting algorithms, but okay, it works. Now, let's make this a little bit more interesting. Instead of doing it this way, what if I replace this data with the stuff that's down here? Okay, there we go. This is a little more interesting. This has got some real data, and of course what this looks like, it looks like a whole bunch of student information. Okay, and if your student ID is up here, don't worry, it was all just randomly generated. All right, and of course, if I ask you the question, is this sorted? Well, that's kind of a difficult question to ask, because what does it mean for something to be sorted? I mean, each one of these students has 3 fields. They have an ID number, they have a name, and the GPA. And if I ask you, are they sorted by ID? I'd probably say no. And if I asked you, are they sorted by name? Well, also probably no. And are they sorted by GPA? And again, the answer is no. It looks like it's a complete random gibberish pile of stuff. And if we were interested in figuring out who's got the highest GPA, well, okay, we've got an algorithm how to do that. However, if we could sort it and put all the big numbers at the top or at the bottom, it would make finding the highest GPA a whole lot easier. All right, but the issue is if I just use this for data and I try to run the algorithm exactly as is, okay, so what's going to happen is it's going to print all the data. This is going to be a mess, by the way. But then I'm going to run across a problem when I hit this line right here. So let's go ahead and run it. Let's make this go away and stay away. Hiding on, I've had enough of you. So should we run it? Okay, so there you go. There's the list of everything. And then there's a crash afterwards. Just to make it a bit easier to see, instead of doing a single print like this, I'd like to turn this into a for loop, please. So for s in data print s, it'll just make it easier rather than wrapping around, okay? So that's all that I've done, is just to try and make this a little bit better, and I will do my usual thing. I will put like one of these separator bars between it so we can see what it looks like before and after. All right, so the before, that's exactly in the same order that was typed in, but I never made it to the after because right here it says that greater than is not supported between instances of dictionaries and dictionaries. Yeah, because remember the way how it works, I take the student at position number 0, this one, and I compare it against this one, and you say, well, which one's smaller? What do you mean it's smaller? Are we talking about the ID, the name, or the GPA? Or maybe a combination of all three? And that's the reason why my algorithm doesn't work, because I'm assuming that I can compare things. Although I can't, although I can't do that directly, there are things I can do. For example, since everybody has an ID, there's nothing stopping me from doing something like this, where I can compare the two IDs, and I can say, if the ID, if the first one is bigger than the ID of the second one, then we switch them. And the good news is the switch happens to take place really easily. It just happens to be that I have to toss in one extra item. To make it visible, I'm going to do this. Okay, so again, just a single print. A single print before and after. So before will be the original version. The one after will be the one supposedly sorted by, well, we're comparing IDs. So guess what ends up happening? Yeah, this will end up being sorted by ID. All right, so this is the stuff before. That's not so interesting. But maybe this one right here is more interesting. Now, take a look at the IDs. Yeah, the ID 60045127, that is definitely the smallest, and the one at the bottom, 60099104, that is the biggest, and of course everything is now put into increasing order. That's actually really convenient, isn't it? But you'll notice it's the same algorithm that I just gave you. It's exactly the same. It's the same for loop and two nested for loops. The inside loop is going through and it's comparing adjacent elements, and if it finds that it's out of place, it's switching. In other words, it's not anything new. It's just that we happen to be using the ID to do my comparison. And yeah, I can switch this to whatever I want. For example, I can compare, say, names, and I can compare name. And when we do this one, there, you know what? I don't think we need the before anymore. We'll just print the after. There you go. That would save me from scrolling. And if we take a look at this, now we've got this interesting situation where, yeah, this is now being sorted alphabetically. And that might be easier if you're trying to find somebody's name, because even if you don't have a computer, I mean, you're not going to do a binary search on your own. But what you will do is you will scan through this really quickly. And if you're looking for somebody's name who starts with the letter O, you're going to very quickly go through this. And if you ever end up as somebody like an R and S, you're going to say, oh, no, it's got to go before. That's exactly how we find this. It's more or less, we're kind of guessing our way. In a binary search, we're going exactly for the middle. So it's good for the computer. It's even good for us. And likewise, if we wanted to, yeah, we could certainly sort according to GPA. Okay, and there we go. And there's the lowest GPAs at the top and the biggest GPAs at the bottom. So again, it's very, very useful to be able to do some analysis of programs. And whenever you're printing things, yeah, usually people will want things sorted to make it easier to find. Give me a second. Now, MySQL Workbench wants my attention. There we go. That should make it go away. All right, but notice that the only thing that changed each time was just the word right there. Okay, it was just this word right here that changed. All right, so here's what I'm going to do. I'm going to introduce something completely strange. It's outside the scope, but I'm trying to get you used to the idea about why Python is about to do something I'm going to show. All right, here's what I'm going to do. Right here, I'm going to pull out, okay. Oh, and by the way, the thing you're sorting on is often called the key. Okay, so right now, this is being sorted according to the GPA key. A few minutes ago, we had it sorted according to the key called name, and before that, I was sorting according to the key called ID. Okay, so what I'm going to do is I'm going to introduce two variables. I'm going to call the key 1, which is going to be data at J. If I can type this, here we go. And I'm going to ask for the ID. In other words, I'm going to go back and I'm going to sort by ID again. Key 2 is going to be data at J plus 1 ID. All right, and all that I'm doing here is instead of calling this data blah blah blah, I'm just going to call this key one, and key 2. Okay. All right. First thing, let me clear this, and okay. So is it back to sorting according to ID? And the answer is yes. I haven't done anything except instead of having these big long things, I've now got them in 2 separate variables. That's all. Because, you know, sometimes by making an extra variable, it can just make something a little bit easier to explain. Okay? All right, so here's now what I'm going to do. I'm going to introduce something new, because nobody ever introduces functions unless the instructor says so, right? I can use functions whenever I want. So here's what I'm going to do. I'm going to define a function. The function is called getKey. Okay? It's called getKey. In other words, please give me the key. Okay, well right now I'm just going ahead and grabbing it. And what I'm going to do is I'm going to pass in a student, because that's what I'm trying to sort. And if I'm only interested in the student's ID, I'm going to return that. A pretty simple function, isn't it? All right. Instead of asking for the ID directly here and the ID directly here, what I'm going to do is I'm going to call my function getKeyDataJ and getKeyData at j plus 1. It's still exactly the same thing. I haven't introduced anything new other than I've added a new function. But in terms of the algorithm, absolutely nothing has changed. This is still sorting. Now, the reason why I did this is because take a look what I need to do now. You see, I can now sort by GPA by basically changing that function right there. I've got it into one place. I don't need to change it twice inside the middle of the algorithm. I just change it in one place. By doing this, it means that this piece of code right here is now completely reusable, and I can reuse it as many times as I want. And when you have code that's completely reusable, you put it into something called a function. And it can now be used for anything. And it doesn't matter if it's students, it doesn't matter if it's integers, it doesn't matter if it's a classroom stuff, it doesn't matter if it's sales information. That function right there that I just highlighted will always look exactly the same. All that I'm doing is I'm saying, well, in order to sort it properly, you have to go and get a key. And where do we get the key? Well, that's inside a function. It's in a centralized location where I can change it. Okay, this is the whole idea behind what they've done in Python. Okay, so let me put this away, and we'll repeat all of this stuff now with the actual stuff that's built into Python. Where my slides go? Okay, so here we go. Sorry, let me drag it over here because I don't want to reveal anything that would be too much fun to explain first. I just want to make sure I've got this in the right order. Okay, we've already done the simple things. And a list of dictionaries, that's fine. We've already covered that. Okay, good. So yeah, it turns out it's really quite simple. All right, here we go. There's a bunch of data. Is it sorted? And the answer is no, it's not. Let me clear the output so we know what we're talking about. There we go. The data is definitely not sorted. If we want to sort the data, well, let's do it the lazy way? Okay, no, we won't call it the lazy way. Let's call it the programmer way, because no programmer, by the way, would ever go and write a bubble sort like this, because first of all, they know that it's slow, and more importantly, they know that there's something built in that can do this for us. So we saw last week that we could do something like this. Okay, here, we can use this as a trace question for a second. When I print this, what do we see? Do I see the numbers, or do I see the students, or do I have an error? That could be a trace question, like an MCQ during the test. What appears? Is it 3, 4, 2, 4, 5, 6, or is it all these students, or is it an error?
It's going to be the list.
Yeah, it's going. They're both lists.
The second list.
Yeah, the second list, because obviously it gets rid of the first one. Okay, all right, good. That was not supposed to be a trick question, but sometimes it could happen. All right, here we go. And if I say, so in other words, the first thing is just kind of hiding. If I do this, what does data.sort do? Sorts the list of numbers, and we get everything exactly in increasing order. It was almost there anyway. Okay, it was like the world's most boring sort. So here we go. We'll add one extra item just so we can see something happen. Okay, there we go. So yeah, that's the sorting. All right, well, let's go back, and what happens if instead of being a bunch of integers, what if you try to sort a bunch of students? Well, the first thing is students will never get in line and say where they're supposed to stay. that's actually true. If I tried to arrange everybody, it'll be a complete disaster. But in the world of Python, if I try to do this, I've got a problem, and notice that the error is exactly the same error that I had a few minutes ago, back when I had my own bubble sort. In other words, what's happening inside the sort algorithm, which is hiding inside that line 23, remember, that's a function, it's doing a whole bunch of stuff. Somewhere, it's doing comparisons between two items. Now, it's not implementing bubble sort. Its sort is much, much quicker, but it still has to compare two items to find out, does this go in front of this one or the other way? And because it's a list of dictionaries, that's why it fails, and that's why it fails saying that, well, I couldn't compare using the relational operator between a dictionary and dictionary. Okay, so we got our problem. So therefore, we can't sort these things. It only works for simple integers. The good news is that, yeah, because people are sorting things all the time, they have included some extra features to help us. Okay, so get this. In order to use this, you need a function. I'm using the same name. Doesn't have to, this could be whatever you want. It could be blah. Okay, it's completely fine. What it takes as a parameter, it takes the type of thing or the thing that you're going to be sorting. Since I'm sorting students, I'm just going to call it student. Okay, so what it is, this is one student. What thing would you like to sort on? Okay, well, I'm going to leave it up to you. Remember, I've got 3 items up here. Which one do you want me to sort by? Do you want me to sort by ID, name, or GPA? Your choice. I heard GPA first, and then we'll do the other one. All right, so what am I going to put in here? Exactly the same as I showed you a minute. I'm going to say go to the student, pull out the GPA. That GPA is actually really, really clever because I got a couple of tricky things in here. There you go. So that's the function. Oh, we just saw it. Okay, but how do we use it? Okay, we use it in what's going to seem a very strange way. So I do apologize. This is the weird and new thing for today. For the most part, sorting is pretty simple, but there's going to be one thing that's going to drive you a little bit bonkers. Okay, and we'll try it. Okay, we'll try it to see what ends up happening. Key is equal to get key. Please sort according to the key that you get when you call the function getKey. Now, you'll notice something weird about the getKey. What seems weird about it? Yeah, there's no parameters. In fact, there's not any of these, but you don't put them here. This doesn't say call getKey. It says that when you sort, use that function. Don't call it right now, but when you need it, call it. Okay, it's a little bit different, and I know it's completely different because whenever we say the name of a function, it's always call it right now and get the result. That's how we use functions, except in this case. This is officially something that falls into a category called a callback. Okay, I won't ask you that question, but this basically says, yeah, when you need it, call this function. Okay, but if I put the parentheses, it actually calls the function right away, and then we'll have all kinds of weird problems. In fact, I can even try it to show you what ends up happening. All right, take a look at this. That's it. If I run this, take a look what happens. Oh, it's one of these things again. Sorry, I should do this. For x in data print x, just the wrapping is a little bit funny. There we go. That's easier to read. Take a look what's happened. It has sorted exactly by GPA. That's actually really cool because, yeah, it's exactly what I did, except I didn't have to write the bubble sort. Oh, and by the way, the sort operation that's provided here is really fast compared to a bubble sort. Like, it's astronomically fast. And I showed you the difference between a linear search versus a binary search the other day. It's like that much of a difference. It really is. It's night and day difference. Yeah.
Do we have to use the word key in the sort?
Okay, so this right here, this is a requirement. Okay, remember, these are optional parameters. This is like when you print and you say sep is equal to comma and it puts commas between everything, or end is equal to nothing and it doesn't print the new line character. That's what this is. So this says this is the key function. This is the function you're going to use to obtain the key. It doesn't have to be called getKey. Like, for example, sometimes what I might do is I might call it getGPA. Because guess what the function called getGPA does? It's the GPA. So in other words, sort based on this one. But again, you don't pass the parameters. That's the one weird thing. Okay, we'll try that in a second. You had a question? So the function doesn't return anything. So which function are we talking? This one? This function here, the get GPA. Oh, for x. Oh, well, I'm just iterating through all the items of data. Remember, so it's a list. So I get everything. It's not a dictionary. All right, so you don't get just a key because that's what happens, of course, with a dictionary. But this is not a dictionary. This is a list. So we get to see all the values. Okay? All right. If you make a mistake and you accidentally put these things in because it's so out of habit, okay, and yeah, don't worry, it's going to happen. It happens to me occasionally as well. When I try running this, I actually get an error. And if you take a look at what the error says, it says that get GPA is missing one required positional argument. That was on line 28. Well, remember, when you call get GPA, you have to pass in the student name. But I don't even have any students that I could pass in. So how does the student get passed in? Remember what I had a little while ago? I said key 1 is equal to get GPA? Yeah. So that's the difference, is the function's going to call this key function, not, we don't call it directly. This simply says there's a function out there, call it when you need it. It's a different thing. Yes, I know it is weird, but there's a lot of places where this does appear. I think this might be the only place that we see it in this course, but if you continue on with the IT stuff, you may see more things like this. Okay, it's basically, yeah, there's a function, call it when you need it, and it's really clever because it makes sorting things really simple. Oh, hey, if we wanted to sort by name, what could I do? Well, maybe I would define a new function called getName, and I may pass in a student. So given one student, how do I get the name? That's pretty easy. I'll obviously have to come up with something a little bit more interesting. And if I said, well, sort it based according, if sort it by using the key function getName, guess what's going to happen? It's going to sort according to, well, whatever this happens to be, name. Okay, and this will be sorted alphabetically. And this is all very, very neat, actually, because it means that this function right here is incredibly flexible, and it can not only sort different values, it can actually sort different types of values, and that's really, really, really neat, because you can actually sort any type of thing at all. We'll have to make up a few of these. Yeah.
Can you use one function for both sorts?
One function for both sorts. Well, here's a problem about using one function for both sorts. What would I return? Okay, so get both. Okay, what would you like me to return? Because remember, this needs to return one thing.
I meant like reuse the function. If, for example, the user wants GPA, then the same function can be used to just change the things within the parentheses.
You'd have to change these.
Yes.
Yeah, you could use one and just change those. Yeah, that's fine. And that's why I initially had the thing just called getKey. Okay, but because I wanted to have a couple of these things, I thought I would just leave them lying around. But yes, that is normally what people would have as a programmer. You'd probably have one function, probably called get the sort key, and it would return exactly the thing that you need. Okay, all right. In fact, maybe I will go back to that. Oh, sure.
Can we sort both name and GPA at the same time?
Ooh, well, what would that mean?
Like both of them is going to be sorted from alphabetic and also the GPA from those two headers.
Oh, well, so...
Two sort functions.
Well, now there's a bit of an issue with this. Now, I am going to answer this question, but I think the question might need a little bit of refinement, okay? Because what would it mean to sort by two? Like, for example, okay, here, we'll pick something very straightforward. This is the very first person. Okay, that's not a problem. Let's make their GPA, let's see, 3.99, okay? All right, just because I need to say this one. So the list on the output is definitely sorted alphabetically by name. Okay, is it sorted by GPA? And the answer is no. Could we sort it by GPA at the same time? Well, yeah, but so you're talking about changing Ahmed's GPA to be 1.76 because it's the smallest? Yeah, because they're tied together. Okay, that's the problem. However, the question that you just asked is actually related to something really important. Yeah, maybe because they're separate, but these things are tied together.
If it's not tied together, we can't do
Then it's two separate things.
Oh.
Yeah, it's two separate lists, sort them, yeah. So this is because we want Ahmed's GPA and the ID to stick together. We have no choice. But there are still things that we can do. Okay, now I got to think about what it was that I was going to do next. Was it what I'm about to do? Okay, well, you know what, we'll move on to it because the question has some validity. But I need to make a few changes. Okay, right now the highest GPA is what? In my data set? 3.99, okay. Yeah, I did that on purpose. I would like to give some other people a 3.99 GPA. Do you want one? Should I just change it in PeopleSoft? Yeah. Unfortunately, I can't do it. But anyway, because this is not real life, it's easy to do. All right. Now, I've got a whole bunch of people with a 3.99 GPA. Okay, that's fair enough. Look, right now, I'm sorting according to name. Okay. Stop. There we go. There we go. So sorted according to name. Okay, no, I'm interested in seeing the high scoring people at the top. Sort according to GPA. Bang, there we go. I'd like it the other way. I'd like to see big numbers at the top. All right. There's something built into the sort called reverse, and it does the exact opposite. There we go. So it'll put the big numbers first, the small numbers, and likewise, if you want like the Z down to A, that's fine. All right. So this has been sorted according to GPA, but has it been sorted alphabetically? Ooh. Now this one is close to what you were asking. Okay. So I thought maybe at first this is what was being asked, and that's fine because this is where I was going anyway. You see, if we only look at the people with the 3.99 GPA, and I ask you the question, is that list sorted alphabetically within those high GPAs? And the answer is no, it isn't. Because if it was sorted alphabetically, we better have Ahmed first, we better have Huda next, we better have Sami next, and then Yusuf, because that would be alphabetical. So can we do that? And the answer is yes, we can. Okay, yes, we can. What you need to do to sort on two keys like this is you need to sort them twice. It sounds really, really strange, but you need to sort these ones twice. And you have to sort them in kind of an unexpected order. All right, so here's what I'm going to do. Data.sort key is equal to get name. Oh, now I remember what it was. I marked it down somewhere on a piece of paper and it's still sitting there saying, yeah, don't forget to show this one. Okay, and if you can manage this, then you'll probably know more than most Python programmers afterwards. So it's kind of like a really clever thing in here. All right, so here we go. Take a look what I'm doing. I mean, it sounds a little strange because it looks like, okay, if I only have line 33, it sorts by name, no question. If I only have line 34, it sorts by GPA from highest to lowest. What happens if I do both? Well, first of all, is it sorted by GPA? Yeah, it is. The 3.9s are at the top. But any two students or any group of students that have the same GPA, they're also now sorted alphabetically. Yeah, so what it does is by calling the sort on the name first, it actually remembers that it was sorted by name. And when you try to sort by GPA, it still keeps the names relatively the same. Okay, it's called a relative sorting. Okay, and yeah, so you can actually combine multiple things together. Okay, so that's kind of cool. You know what, just let me make a couple of extra examples. Let me pick some people with the low GPAs. Let's see, 1.76, so let me change this one. Does anybody want me to change their GPA to 1.76? I might be able to do that inside PeopleSoft. No, don't worry, I'm not going to. Actually, I can't change anybody's GPA. All right, but here you go. Just so we got a couple of cases. We got the highs at the top, we got the lows at the bottom. So there's a bunch of people at the bottom with this 1.76 GPA, and take a look at this. They are also sorted alphabetically within their group. And that sometimes is really useful because sometimes you're looking for something and you want to have it sorted on two different keys. That falls into exactly, can I sort on two keys? And the answer is yes, you can. But this is what it means. You obviously wouldn't want to take the GPAs and mix them up with people. If you did, it's possible you'd have to rip the dictionary apart and stick all new values in again. So it would be possible, but I don't think it would be very popular. Okay, and there might be cases where it is useful, but I don't think in terms of GPAs it would be. All right, so remember the way how this works. Sort first by alphabetical name. Get all the names put in alphabetical order, but then move things around so that the GPAs are in the correct order, but never switch the order of the alphabet. So in other words, if somebody's last name begins with a Z, it will still appear after the person with the A. It'll move up with them, but it won't go past. Officially, it's called a stable sort. A bubble sort is actually a stable sort. But an interesting thing, because you might say, oh, I can just switch these two around then? Because, I mean, that's doing two sorts. Sort first of all by the GPA and then sort by name. Unfortunately, when you try that, it does not do what you want, well, quite as what you want. In fact, it's also not very helpful. All right, so the question is it sorted by name? And the answer is, yeah, it is sorted by name. That was the very last thing. Is it sorted also by GPA? It is, but we don't have any examples. There's no examples. Well, I can make an example. I guess I can make like an extra person in here. Okay, and what I'm going to do is I'm going to have another Ahmed with a GPA of 1.2. There you go. So what I did first is I said sort by GPAs, and all the GPAs went in place, and then I said then sort by name and make sure that the people with the lower GPAs don't end up with above the people with the higher GPAs. So you can see right here, it was guaranteed that the 3.99 came first followed by 1.2, but that's only because the name matched, which of course doesn't make any sense in our particular case. Even the ID, of course, ended up matching, so not much sense. So unfortunately, you have to do something a little bit funny. And by the way, if you do some stuff with Excel, you probably had to go through and sort multiple columns. You sort first by this, then by this. The only thing that's a little bit weird with Java sorting, or sorry, Python sorting, wrong course, is you have to kind of put it in the reverse order. So if you want to sort by GPA first and then by name, the order goes in backwards. That's the only thing that's a little bit weird. Okay, all right, but very, very flexible, because now that we've got this ability, we can basically sort whatever we want. And I can introduce some really, really unique sorting things. So to demonstrate a few of these weirdness is, let me try this. Yeah. That is no point, because it was just a question, how do we get both? And the problem is we don't know what to return. Return both or return, because you can only return one thing. Okay, so that kind of put a stop to it. So sorry, I forgot to erase it. So now it's gone. All right, in fact, I'd like to get rid of this one. I'm going to go back. I'm going to call it get key, and I'm just going to call this get key. Oops, sorry, get key. We'll go back to something simpler. Okay, if I run this, what's it going to be sorted by? GPA, low to high, because I've got the reverse out. All right, now let's start doing some really, really bizarre things, because this can be a whole lot of fun, or it can be really, really strange. I want to make up a bunch of different cases for what to return. Okay, so let's see if you can predict what I'm up to. This would be valid, this will run. So this is going to be one of these, let's predict the output of this. What am I sorting by? Okay, yeah, the last digit. I was going to say, when you take an ID number, any integer modulo 10, what do you get? You get exactly the very last digit. So what I should end up with is I should end up with a sort where numbers that end in 0 should show up first, followed by numbers that end up in 1, then 2, then 3, then 4, and so on. And that's exactly it. So now I can start doing some really bizarre and very interesting little things. So if you're looking for, hey, give me everybody who's sorted so that it's based on this one, I can do things like that. Yeah, I can do whatever I want. That one's kind of interesting. How about this? Take the name, if you spell it correctly, No, that's reverse. Yeah, the last character is everybody's name. Here, take a look at this. You see, we end up with Fatma, Leila, Ish, Nora, Rania, Huda, Muda, and then Zainab comes next. So everybody whose last or whose name ends with the A shows up first, and then people with B, and then people with C and D, and so on. And that's kind of clever. I mean, I don't know, useful? I don't know, but hey, there's all kinds of clever things that you can do with it. How about this one? How about this one? This one's kind of clever as well. Because it's just a string, so what does the length of a string give you? Well, number of characters. So what am I sorting by? Yeah, the length of the characters. So what am I going to see at the top? I'm going to see people with shorter names. And at the bottom, people with longer names. There you go. So if you want to know who's got the shortest name, that's one. And of course, there's many people here with the longest name as well. And you might say, yeah, but those longest names, I want the Z at the end. Okay, well, that's a second sort. Yeah, sort it again afterwards, or sort it before, actually, is the way it works. All right, so we got that. Okay. Again, I don't know what the purpose of this would be, but this could be kind of fun. It should work. Okay, so the student GPA, so take a number like 2.95 as an example, and what happens if you call int? It gives you just 2. So if I take 2.95 and subtract 2, what do I get left? 0.95. In other words, what I'm doing is I'm sorting according to the stuff that comes after the decimal point. Again, I don't see any purpose of that, but 0.18 comes before 0.20, which comes before 0.41, which comes before 0.455, 0.57, 0.67, and so on. Okay, I know the 0.2 looks kind of weird because it's missing a 0 at the end. All right, so yeah, you can do some very, very unique and clever sorting, and you can basically sort anything any way at all. All right, let's cause some real trouble now. All right, back to the easy one. Okay, this is not meant to be tricky. This gives me GPAs. Okay, good. GPAs sorted from lowest to highest. All right. Oh, it's getting worse. Okay, Control Z. Control Z. Okay. Okay, can we sort that? So, some students don't have a GPA. That's unrealistic. No, it isn't. When a student first starts here in the first semester, they don't have a GPA. Can I still sort them? Yeah. Okay, but if I try running this program, I think I'm going to run into a problem. So please sort according to the GPA. So there's the function for going and getting it. If I run it, it says, ooh, couldn't find it. Yeah, well, that's because what happened is, while it was going through comparing things, it said, okay, give me the GPA of this student, and it said, ooh, there isn't one. That's why it blew up with a key error. There's no GPA. Yeah.
So what does key get key mean then?
Which line? This one right here? This is the name of the function that I'm using to obtain the key that I'm going to use for sorting.
You're making a variable called key?
No. You have to be very careful about what this is. I'm not making a variable called key. What I'm doing is I'm calling a function and I'm passing in as the parameter called key the function called get key. Okay, give me 1 minute and then let me remind you about how this works. Okay, so this is supposed to be midterm, by the way, but that's okay. I don't mind repeating. Remember, you have a function, you have an A and a B, and you return A plus B, just something very simple, and I'm just going to say print func 1 and 4, and let me get rid of the rest of this stuff.
So for you don't put just open the brackets and put the variable. That's right.
Okay, unterminated line of string. Okay, here we go. 1, 2, 3. All right, so just ignore all the commented stuff. Okay, is this okay? Yep, good. All right. Ooh, sorry. Let me do this one first. All right. If I run this, what do I get? -3. Very good. Okay. So just to remind you what I'm doing in here. Remember, I can set exact parameters this way, and what this would end up doing is this says, I don't care if B comes first. Sorry, I don't care that the 1 comes first. 1 is referencing to B, so the value of B will be 1 and the value of A will be 4. This would end up giving us a +3. Okay, so when you call a function and you provide something is equal to something, you're not making a variable, you're saying, please set this parameter to be this value. Okay, it becomes really important in certain functions. For example, the print function. If I run that print function right now, what do I see? It's not a trick question. I see a 34 and a 55. And what goes between them? A space. If I want, I can say sep is equal to x, and that's not creating a new variable. All that I'm doing is I'm saying, for the separator, please use x instead of a space. Okay, so that's what that means when I say key is equal to. Okay, I'm saying to the function, when I call you, the parameter called key is equal to this, not to be mixed up with reverse. Okay, that's the first one. Now, that's the first part. So it says, yes, please set the key equal to this. But we don't set the key equal to it. What we need to do is we need to give it a function that's going to be called later. Not now, but later. And that's why we leave the parentheses out, to say don't call it now, call it later. Okay, so it's something called a callback function. So what I do is I call this function up here. Okay, good. Okay, so now we're back to our original problem. All right, why do I have the error? Because remember, it's always important to understand why do we have the error. I think you've probably discovered already in this course. It isn't about knowing what to do, but it's knowing how to fix your mistakes, because guess what? You're going to make a bunch. Okay, we're going to make them too. All right, so what does it mean, key error? The word key error means that you tried to find something in a collection, might be a set, might be a tuple, might be a list, might be a dictionary, and that key didn't exist. Oh, it says, the only thing I've got here is I got a list. Okay, we don't have these, but you know, on line 29, I'm trying to pull out a GPA, and I think it's pretty clear that what's happened is I've got 2 students in here without a GPA. So when the sorting algorithm tried to compare those two, it said, oh, hey, there's no GPA here. What do I do? Well, a crash, I mean, I guess that's one option, is just to crash and not do anything, but I still might want everything to still be sorted. So how do I deal with this? You got a couple of options. One, you could go through the list and get rid of everything that doesn't have a GPA, do that in advance, but instead, what I'm gonna do is I'm gonna do this. How about if GPA is in the student, then return a GPA. Oh, what if it isn't there? Oh, well, no crash, right? Okay, let's run it. Oh, when I run it, it says now I'm having problems comparing floats, which of course are GPAs, against none. Because what gets returned if the GPA wasn't in the student? Well, because I didn't put anything, it returns none. Okay, well, you can't compare nuns against floats. But what I could do is I could put an else in here, or you could even just put a return, it would be fine. And I need to return something. What do you want to return? It depends on where you want this to appear. All right, so somebody suggested 0. Okay, so if the student doesn't have a GPA, we'll assume that the GPA is equal to 0. That certainly seems reasonable, and you see where it ended up putting these people in the sort. It put them right at the top above the people with the GPA of 1.2. That probably makes a lot of sense, okay? And that's a really good thing. If I wanted all of the non-GPA students to appear at the end, for whatever reason, I'm not sure why, then all that I'd have to do is if I made a number like 5, that would be guaranteed that they would end up at the end. It doesn't give them a GPA of 5. All that it's doing is says, okay, for sorting purposes, pretend it's a number 5. That's all that we're doing. For sorting purposes, we're going to be. And what this will happen is this will put you at the very end of everybody because nobody else will ever have a 5. So you can control the sort of this through some very interesting means. And as I say, these functions, so here's a case with an if statement, yeah, they can be very mathematically complex. Like, for example, maybe you want to sort where people have high GPAs and long names. Maybe that gives you a score to be higher. Maybe it's some kind of a competition or something where the people who have really long names and really good GPAs, maybe they're the people who win the competition. And you can do things like this. So, you know what, just for fun, here, we'll do this. So let's take the length of the student's name. Okay, and what I'll add to it is I'll add to their GPA. I mean, that doesn't even exist. GPA, oh, sorry, student's GPA. All right, there you go. And, oh, because I got rid of these guys' GPAs. All right, I'll have to give them some GPAs again. Okay, 2.3, and give this person a GPA of 3.45. There we go. So that would be the sort based on that. I have no idea what it means, but that would be the result. Don't worry, I never ask anything crazy like this. Yeah. Not make a GPA key. Oh, what do you mean? Do you mean adding an extra GPA without anything in here? Oh, okay. So, hey, that's a reasonable. Hey, that's a really cool question. Okay, trace question. Is that allowed? It has nothing to do with the sorting. It fails on line 25 in the syntax error, and it says expression expected after dictionary key and colon. Yeah, dictionaries need to have a key and a value. So you need to have a value. Now, if you would like to have the value none, that's fine. But obviously now I couldn't sort according to GPA because now I got this none, and I'd have to have an if statement inside my get key to make sure that I knew how to deal with it. Okay. All right. So simple, complicated. It's kind of, okay, it's on the edge. Before I started doing a bunch of weird stuff, okay, it wasn't bad. I mean, it's pretty easy for sorting on one thing. As long as every record has a GPA, it's easy to sort. If everybody has the same thing, it's fine. If you had to sort on one item followed by another item because you wanted to group everything together, it's not bad. You just call sort twice with 2 different keys. Okay, and if you had to do it in 3 things, fine, it's just 1 extra. All of the weird things that I just did right here, these are really kind of special cases. It's not something I'd ever ask in a 1201 course. The first couple are certainly fair, though, because it really is just 1 extra item. The only thing that's kind of a bit weird is, yeah, you don't put parentheses here because you're not calling it on line 34. You're simply telling the the sort function that there is a function that will be called eventually. Okay, that's it. But otherwise, it's pretty nice to be able to sort things. And you can do all kinds of things with this. For example, I could sort lists of tuples, and I could sort according to the length of the tuples. I'll leave that as an exercise for you guys to try. And I can always sort, again, if I have more things in here, hey, if you want to try something, take your books from the library assignment, put them into a list. Okay, that'll be 1 step. And then sort them according to the number of copies, and then sort them according to the number of people that currently have the copies borrowed. You'd be sorting on the length of the list of the current borrowers. Just something to try. Let me get back over to the slides because I think I am probably finished. Okay, I'm pretty sure there's nothing else in here. I've said everything, including more stuff that you probably didn't want to hear. All right, so here we go. So the key parameter for sort and sorted. So there's the example of sorting things. I've got this function, it's just generics called getKey, and obviously you can replace it with anything. And if you want to sort multiple times, it's okay. You just have to kind of call it in the reverse order. That's the only thing that's a little bit weird. All right, and you can see what I've done is I made 2 sort functions, one for getting the GPA, one for getting the name. All right, and this one right here is, can you sort a tuple, a set in a dictionary? Because that's a question that keeps popping up every semester. I finish up and say, okay, we're finished. And somebody says, can we sort a tuple? Okay, well, let me ask the question without even looking here. I guess you can look, is can you sort a tuple? Well, no, because you can't rearrange a tuple. But what you could do is you could take the tuple, turn it into a list, sort it, and then put it back into a tuple. Okay, you're not really sorting the tuple, but what you're doing is you're creating a new tuple that has the same elements in a sorted way. Can you sort a set? Well, hopefully you remember that sets are unordered. So you can't sort a set. You can certainly take all the elements in a set, put them into a list and sort it. That's allowed. Okay, but if you put them back into a set, that will be unsorted again. And the same thing is true about dictionaries. You can't sort a dictionary because it's an unordered collection. Dictionaries have the ability to find things quickly, but not to keep order. That's the trade-off. You get order or you get speed. And that's actually true in a lot of data collections that we have. Okay, so it says right here, it doesn't even make any sense. So the good news is, that's all that I've got. Okay, do I have to say anything? Let me pop open the syllabus just for a second, since we've got a couple of extra minutes, and see if I've got anything that's coming that I need to mention. Okay, so somebody was in here earlier asking about what modules and so on were for the lab exam. So lab exam, November 22nd, sorry, it's again this Saturday morning. We have tried this before to try and put the lab exams inside the lab sections. It doesn't work. It's completely unfair to the people at the beginning of the semester, or at the beginning of the week, because they leak all the questions to the people at the end of the week, and everybody on the Thursday gets really high marks, and the people on Sunday get really bad marks. So I don't want that. It's just not fair. I know bringing you in on a Saturday is also not fair. I apologize. It's the size of the course. If we ever had like a common exam period during the week, that would really make life considerably better. So the lab exam, yeah, unfortunately it's 8 till 10. I will once again post the room allocations just before. Mostly people will end up in the same room as last time, but there's a couple of changes. The material includes lists, including 2D list sets, tuples, and dictionaries, and of course nested structures of all of these. So don't walk in and say, hey, there was a list containing a set containing a list containing a dictionary. Yeah, that's fair. Yeah, obviously, I'm not going to not every question is going to be that complex, but yes, please expect everything to contain like a combination of things, because lists on their own don't have that much practical use. Dictionaries on their own don't have that much practical use. List of dictionaries, yeah, this happens all the time. A dictionary full of dictionaries also happens all the time. That's the reason why those assignment questions showed up. Okay, it says everything from the start of the semester, including infs 1101. I included that just so somebody doesn't come and say, hey, you made me do an if statement, I didn't remember how to write an if statement. Okay, so yes, it's everything. No, I'm not going to ask you to do a flow chart. Okay, I'm just saying that everything that's being covered, yes, it's the full thing. We will have 5 coding questions. The first 3 questions, worth 70% of the test, are relatively straightforward. Okay. If you have practiced everything, relatively straightforward. The last 2 questions are more challenging, all right, but they're worth less marks. So again, it worked well, I think, on the midterm. So same idea. Yes, you'll have access to the interpreter to test your code. Every time you'll be asked, to write a function, you'll pass in some parameters, and your function will need to return something. Will you ever print something inside your function? No. Feel free to print things for testing, but please remove it afterwards. Okay, and don't forget to return things. Yeah.
Do you, after writing our code, copy the best dictionary too?
No, not the dictionary, just the function. Just the function. We have our own testing stuff, which is different than the ones you have. So if somebody says, ooh, I'm going to hard code it and say, if the number of items is equal to 5, then I'm going to return these values, it doesn't work. You actually have to solve the problem. Okay, so just the function, not anything else. Points will be awarded based on the correct results and the types being returned. So sometimes people return the wrong type, and they might return a string containing true or string containing false. Those are very different than true and false. You still get some marks for it, but there's a penalty for returning the wrong type. And the less challenging questions do have a small number of points available for correct logic and so on. But generally, you know how this is. A lot of the programming courses unfortunately have to be roughly the same, and that is, if everything works, then it's usually pretty good, and if things don't work, especially if the syntax errors, you can't expect very many points here. Okay, just to make you aware, don't expect really good marks if programs don't run and they produce really bad results. Okay, at any point, I've included something here to say you can always assume that the inputs are valid. So if we give you a list of integers, you can assume that it's always integers. And we're not going to trick you and stick in strings. Okay, so like, for example, what I just did a minute ago where everybody had a GPA except for one person. Okay, I won't do that unless it actually says, watch out, some people don't have a GPA. It'll be very, very clear. So we won't trick you and say, hey, you didn't handle this case. That's unrealistic. All right, that's the first thing. So basically everything, somebody did ask about something. So let's pull up the syllabus for a second, and I think we're probably good to go. Okay, so the question was the exercise set. I believe until this exercise set right here, number 9, is probably worthwhile because if you look at the content, it is dictionaries. It's nested dictionaries. That's fine. Exercise set 10, on the other hand, let's find out. I can pull up in a... where is my section? Okay. Exercise set 10, on the other hand, wouldn't make any sense because I believe that it's something a little bit different. But hey, let's look at it and see what it is. All right, what does it say? Actually, that's week 10. Sorry, exercise set 10. Oh, nothing. Yeah, so it depends on exactly how your lab instructor worked. We didn't even cover exercise set 10 until next week. And even if we did cover exercise set 10, I believe that it has something to do with sorting. Oh, yay, so you're not going to be expected to sort anything. Yeah, that's true. You won't be expected to sort anything. Okay, but all of the other things, yeah, definitely. All right, and let me see, is there anything else I want to say about this syllabus? Okay, don't forget that the assignment is due on Thursday night. If you're looking for the full marks, the Dropbox is still there for 2 days afterwards, but you probably don't want the 50% penalty. I'd recommend trying to get it in on Thursday night. Roughly, I think it should go pretty well. I know people are finishing it already. Let's see, so we got the lab exam, and then of course there's always, I will do a lab exam review next week. We'll grab some problems, I'll solve them. I got a big set of problems that we can pull 2 or 3 of them out. Later this week we'll cover files, and I will do some CSV files and exception handling. And then there's always a question, well, what are we going to stick on the final exam? Okay, well, I will post a scope document with the final exam, but basically you can expect the final exam will look very much like the midterm in terms of the size. It's 2 hours. There will be some MCQ questions and there will be some programming questions. And somebody will say, yeah, but we just did a lab exam. But I didn't ask anything about sorting, and I didn't ask anything about files, and I didn't ask anything about exception handling. There we go. So these are the things that can go in. So there could be a little bit of that, and there might be something simple, like maybe there's a little list of dictionary problems as well. But what I could always do is give you a list of dictionaries and say sort it, because now we know how to do it. Okay. Okay. I think that's all.
Doctor, is the assignment enough for preparing for the lab exam?
No.